Hi, I'm Brian with Pioneer Builders. This channel is devoted to all things design, construction, operations, maintenance, and even repair. We've been building houses for quite a few years, and while we try to do things right, sometimes things go wrong. In this particular case, you can watch a previous video where I explain why we have water in a crawl space. Part of the solution is we're going to have a sump or a submersible pump in order to remove the bulk water. However, just because you have a sump doesn't mean it's going to work, because now we're using mechanical means to move that liquid water. What do we need for the mechanical movement of that water? Electricity. What often happens in our area when we get the heavy rains is we lose power. Now, the way we design and build our homes is we always have a transfer switch and a receptacle so that somebody could use a generator to energize their house in the event of a power failure. However, not every homeowner is going to have one. And so, if this sump goes out because of losing power and there's no way for the backup generator or the generator to work, we need some redundancy to this system. And that's where this battery comes in. The sump system actually has two pumps. So the first sump runs off of line voltage, and to be fair, most of the year when heavy rain events would happen, that's how we're going to take care of the water. But we need a backup on the off chance that we lose line voltage to the house, or let's just say that there is a generator and that generator stops working, or it runs out of fuel, or maybe the homeowner's just not home. Now we'll rely on DC power in order to have that backup pump working. So in this video, I'm just going to talk about the battery. You might not think that there's very much when it comes to batteries, but you might find this interesting. I know that I do, and so at a minimum, it helps me to do some research, learn some things, and hopefully I can distill that down and keep it somewhat interesting. When someone's doing design, they really should get deep into the specs depending on what the item is that they're designing. So in this case, we're going to be moving water, and we want to make sure that we meet the manufacturer's specification for the sump. That system that we're going to be putting in. All of the elements of the system need to work together. Now, we could have bought a battery with that company, but I chose to go and just buy one using O'Reilly's Auto Parts. Excellent website. I did the research because the minimum specification was 105 amp hours, and it also needed to be a marine battery. So I got online, did some research on it, then I ended up going into a local O'Reilly's store to see if I could buy the battery there. They didn't carry this battery. So I went back and forth with the gentleman. He was at his screen. He tried to find an equivalent or something that could be used. I was on my phone, and as it turns out, it was actually cheaper to get this battery delivered to me than it was for O'Reilly's to ship it into their store and then me to pick it up. But it was still nice to meet with the guy. They have so much experience. So I'm glad that I did that. It was time well spent, but I ended up ordering this online and got it delivered, did a little bit of research. And so now what I'm going to do is it's about a 2-minute clip where I show you what the screen looks like for the item that I ordered. After that clip, we'll come back and I'll explain more of the specifics on what's contained in kind of their specification description. Thanks for watching, and I really hope that you learned something. This is the O'Reilly website here. I had done a little bit of filtering. It was actually kind of hard to find one that was big enough, but I wanted to at least walk you through some of the specifications here. So this is the Super Start Fleet and Heavy Duty Battery Group Size 31. We'll talk about that later. You can see that the price listed is $243.99, but you have to add $22 if you're not bringing a battery for basically replacing it or recycling it. So here's a couple of pictures of the battery. You can see this is the handle whereby you would hold the thing. Here's the terminals. You've got some zooming capability. And then there's the last side picture there. When it comes to the details, notice the height is 9 3/8 inches, the width 6 3/4, and then this sucker is heavy at 67.5 pounds. You want to make sure that if you've got a sump or wherever you're going to be using this battery, that the compartment for it will be able to receive that. There's cold cranking amps, reverse capacity, marine cranking amps, the flush manifold vent cover, the unit of measure, battery type, length, terminal type, voltage, group size again, and then the amp hour. Now this is saying 110. I'll take a look at the battery. I think it's showing 105 on the battery itself, and then this positive terminal location. So I wanted to give you an overview. Now you can see the visual that if you're looking at battery specifications, this is what you're going to see. But I'll explain what various components here actually mean. Pretty interesting stuff. I really hope you enjoy this. Well, now that you've watched the video, let me go ahead and take you through some of these specifications. We already talked about the height, width, and weight. Let's just say you were going to hang this from something or support it over the top. You'd want to make sure that the brackets, the hardware, the structure could support it. Now it's under 100 pounds, probably not going to be an issue, but those are the things you want to be thinking about when it comes to specifying. This sump system is going to be resting on the ground, so to use, is it Newton's third law, there will be an equal and opposite reaction. The earth will be able to support this. But even then, you do kind of want to think in terms of mud, and I don't want to say the bearing capacity of the soil, but you do want to think about this. Setting this in sand might not be the best idea. So a lot of things that are interrelated here. Now, how about cold cranking amps? What are cold cranking amps? Really, it's referring to a test method to see what capacity of something is. So in this case, and bear with me, I want to make sure I'm accurate and I don't have all of this stuff memorized. It's the number of amps a 12-volt battery can deliver at 0 degrees Fahrenheit while maintaining a minimum of 7.2 volts. So what does that mean? This is a 12-volt battery. That means that's what its potential is. It has the potential of 12 volts essentially stored in here. So if this battery was at 0 degrees Fahrenheit and it was delivering 7.2 volts, how many amps would be delivered? 800. Bottom line, that's a lot. This thing it's a beast. It is heavy just to lift around. So 800 cold cranking amps. It's pretty big. What's the reserve capacity? In this case, it's 200 minutes. The reserve capacity can also be called reserve minutes. That's the number of minutes a fully charged battery can sustain a designated constant load, so usually 25 amps, before it is fully discharged. So this one would have over 3 hours for it to run before it's depleted at a 25 amp draw. Again, you'll kind of get the idea. This thing is a beast. This thing is a monster. It has a lot of capacity. Now it talks about marine cranking amps. This one is 1,000. You can take your cold cranking amps, multiply it by 1.2 to get this number. But here's the marine cranking amps. Again, it's a test. In this case, it's performed at 32 degrees Fahrenheit, which just so happens to be the freezing point, for 30 seconds without falling below 7.2 volts at the battery's MCA rating. So a lot of technical things here. So what does that actually mean? Well, I'm going to go ahead and hit pause, and then I'll pick this up and then keep on going. So let's give a little bit more of an explanation for that. The cold cranking amps, remember, was at 0 degrees Fahrenheit. Now we're doing something similar, but it's at 32 degrees Fahrenheit. Because it's warmer, it's able to supply more electricity. And so in this case, we went from 800 cold cranking amps to 1,000 marine cranking amps. It's just showing that it's producing more. But again, it is that measurement. The battery type is an AGM. An AGM means absorbent glass mat. Basically, it's an advanced type of a battery. Top-notch, super, it's just a heavier duty, very well-made battery. One thing I did want to touch on too is what makes this a marine versus just a standard battery. Well, we have to think about what a battery in a car does. Really, the battery in a car is just to help start the engine. And then while I'm no mechanic, I would say combustion takes over from there. Maybe in an EV vehicle, it'd be something else. I'm not an expert on that. But think about a marine battery when it comes to a vehicle. When you've got that motor on the back of a boat, once it gets started, the combustion is what's going to be able to move the propeller. But there's still other things that require electricity on a boat. So that's what the marine battery would be able to do, is not only start something, but be able to also supply electricity. So in this case, for the sump, that's what we want it to be able to do, is to keep another pump, that backup pump, actually running. They also just frankly tend to be stronger, more robust in their construction. So that's, put simply, the difference between a standard battery and then this, what a marine battery is. As we went down there, it did show what the length of it was. The terminal type is a top post. The voltage is a 12 volt. So again, that's referring to what its potential is once it's drawing, how much capacity does it have? With the terminals, you've got your neutral and your positive here, and what ends up happening is in between here would be the device. Energy is going to come from here, hit the device, and then go out through here. So pretty basic as far as that's concerned. All right, let's see what else we have here. Oh, we did touch on that there is a group size. So now we've got an acronym, BCI. It is just amazing how many different institutes there are out there for regulating things. In this case, the BCI is the Battery Council International. So it is good to have standards. Definitely would help with spec writing. It would definitely help with making sure that we get the right unit so that we do the installation according to manufacturer's instructions, if that's called for. In this case, it's 31, group size 31. And then we talked about the amp hour. This says 110, and when I look right on here, I'll do a little video looking more closely at this. It actually says 105 AH, 105 amp hour. So you can't always rely on what you see on the internet. This is going to meet the spec for the design. But if you look online, it looks like it's going to be oversized. So that's good to know. And then it also mentions the positive terminal location. We just talked about that a second ago. And so when it comes to configurations, maybe in three-dimensional space, we do have to consider how is everything going to connect up in the real world. Not an expert. I'm going to guess that that's pretty standard to be on the left there. Oh, one last thing then about the amp hours. It's basically how many amps the battery can deliver in an hour. So in this case, it can deliver in 1 hour 105 amps. Pretty heavy duty. So there you go. That kind of takes us to the end of running through the specifications here. Now we'll go ahead and take the camera and do just a quick little walk around and show you the battery up close. Here's what the battery looks like up close. So we can see that it's the Super Start Marine AGM, and there they say absorbed glass mat. So that's going to have some special design inside there and construction. Looking around to the side, there's just a standard warning there, but we also see a date. There's also a date sticker at the top here. There's the positive terminal, there's the negative terminal, and for the most part, this is relatively boilerplate information here, but this is where we would get into the specs. So we see the 12 volt, we see the cold cranking amps at 0 degrees Fahrenheit, that's 800 CCAs, 200 minutes for that reserve capacity, so that's a unit of time there, and then 105 amp hours, 20-hour rate. So pretty interesting. Lots of little bits of information, but it really does make a difference when it comes to the performance of the piece of equipment. Well, that brings us to the end of our video. I hope you enjoyed it. I know it got in fairly deep into the weeds, and as with so many things that I deal with in construction, I'm not going to be an expert on everything. I don't know if they have battery engineers, but certainly an electrical engineer would know this a lot better than me, even a mechanical engineer. But I do like to know a little bit about a lot of different things. And something else that I hope this video and these types of videos help with is I get to filter it. It's being used in a practical way, and then you get to watch it for what, 10, 15 minutes, something like that. And hopefully open your eyes. Hopefully it's interesting, but maybe too there's some practical application in your life with what you're dealing with. So again, I'm Brian with Pioneer Builders. Thank you so much for watching this. I'm sorry, I forgot something. There was one more thing that I wanted to cover, and that's cost. So here's how it itemized out. So $243.99, then adding a charge because we weren't recycling or taking back a battery of $22. The shipping was actually free, tax $23.94. The total was $289.93. So if you're a homeowner doing this, you can just pay that straight across the board. You have some time into procurement, maybe picking it up. But if you're a general contractor or a remodeler, make sure you know what your markup is, because that's the only way to make money as a builder or remodeler. Now, I do know a remodeler who doesn't mark up, I think he doesn't mark up subs, something like that. But in any case, it's pretty standard practice to mark up materials. So you have to factor in your time, you have to factor in your overhead. There's all sorts of things that can go into what your markup is. But bottom line, you could also choose just to pass it through, or maybe you're a cost plus type builder. I'm not saying what anybody should or shouldn't do, just mentioning some of those things so that you're taking more factors into consideration. I probably could have bought a cheaper one too, but I chose not to. For this amount of money, this is all coming out of the company's pocket. We're not charging the homeowner for this work. So the markup isn't really a valid concern, you might say, for this particular project. But if I ever did something like this on another project and I was charging for it, I would have to be thinking along those lines. So hopefully talking about the finances, the economics, helps you out as well. Okay, let me finish the outro. Here we go. I hope you learned something.